Okay, let's start our next video. It's classifying matter, elements, compounds, and mixtures. I already started this in class with elements and compounds. I'm going to review those again and go on to mixtures. If the computer acts right. It did, good. Alright, pure substances, a sample of matter that has definite chemical and physical properties. All particles behave the same way. Another way of saying this is that all particles are exactly the same. So when you have a pure substance, like water, every particle, in this case, is a water molecule made up of two hydrogen and one oxygen. Another example would be copper, which is something I showed you in class. Copper is also a pure substance. Every atom, in this case, not molecule, is a copper atom. All right, let's move on to elements, the first type of pure substance. This is a pure substance that cannot be separated into simpler substances by physical or chemical means. If it is found on the periodic table of elements, then it is one of the elements. So I know the symbols don't necessarily make much sense right now, but if you look at the periodic table that we have in class, or any periodic table that you find, not only does it have the symbols, but it should also have the name. And if that name is one of the things you're trying to figure out as an element or something else, then it's on the table, it's an element. Okay, next up, the three categories of elements. The first category is metals. That's the largest category of elements. The majority of the periodic table is made up of metals, and they are on the left-hand side. Metals are shiny, good conductors, meaning they transfer energy very well. Malleable, which is a review word. That is something that can be hit or bent and not crack. Ductile, meaning it can be pulled into wires. And the last characteristic, usually solids at room temperature. Yes, the majority, if not all, metals are solids at room temperature. There is only one, and we went over that in class. That one is mercury. Mercury is a liquid at room temperature. Nonmetals are the exact opposites of metals. They are dull, meaning that they're not shiny. They are brittle, meaning that they are not malleable or ductile. Brittle, meaning that they crack very easily or shatter. They are poor conductors. And approximately half of them are gases at room temperature. Some could be solids, some can also be liquids. Moving on to the third category, the smallest category, which is metalloids. These are known as semiconductors because they can conduct not as well as metals and not as poorly as nonmetals. They can show properties of both metals and nonmetals. There are only 7 metalloids on the periodic table, or in that case, on Earth, or in the universe, actually. There are an example of one metalloid that shows properties of metals and nonmetals is boron, and that was something, if you were doing the homework, you would see. Boron is shiny like a metal, but it's not a very good conductor like a nonmetal. All right, now on to something new. Ignore that. Compounds. I'm sorry, we did go over this. I was thinking of mixtures was next. Compounds are the second pure substance and the next and only other pure substance. It's composed of 2 or more different elements joined by chemical bonds. Sorry about that little pause in there. Yes, it is a pure substance composed of 2 or more different elements joined by chemical bonds. The elements are going to combine in a specific ratio. So when you have water, it's always H2O. If you don't have 2 H's and 1 O, then you don't have water. And H2O is the chemical formula for water. It's taking the element symbols and some numbers and telling you what the ratio and combination is. Water can only be separated by chemical means and not physical means. We will get into more what physical separations are and chemical separations. So you have to react H2O in order to react it with something or make it react in order to separate it into hydrogen and oxygen. Just a reminder, NaCl is salt, table salt, Na as in sodium, Cl as in chlorine, and carbon dioxide, di for 2. All right, let's move on. Come on, computer. Okay, mixtures. This is the first non-pure substance. So the first 2 elements and compounds were pure substances. Here's our non-pure substance, and this is new. Mixtures are a combination of 2 or more pure substances that are not chemically combined. So they're held together by physical forces, not chemical. So there's no bonds between the pure substances in this case. No chemical change takes place. So there's not going to be any bubbling or change in smell or drastic change in color. There might be a mixture of the 2 colors, but not a drastic change in color. Each item retains its properties in the mixture. So I'll get into that in just a second once I say that they can be separated physically. So each item retains its properties in the mixture. best thing to use would be salt water as an example. When you have salt water, you take salt, you put it into water. The salt is still salty, the water is still like a liquid, the water would still boil at its own temperature if it was just water, and the salt would boil at its boiling point as well because that's salt. Putting the two of them together does change it slightly because they are working together, but their individual properties do not change. Okay? And this is just showing you how you can separate the different things that make up different rocks, as you guys know that there are different substances that are in rocks, and then they're slightly different colors to show that. Tap water has minerals inside it. If you want to separate those out, you distill it, and we'll be going over what distillation is in a second. So, mixtures versus compounds. This is a pretty in-depth table that I want you guys to look at, just to give you a better idea of how to know the difference between the two of them. I'm not going to really spend too much time on this table. I just want you to take a look at it. So pause it on this, take a look. If you want to copy it down, feel free. It's on here if you need it, okay? It's just repeating things pretty much the same that it was before. So variable composition, I will say, that means that it's not a definite ratio, not a specific ratio. Definite composition means specific ratio. Okay, moving on. So there are two types of mixtures. One of them is homogeneous. Homogeneous means that the particles are going to mix in an even distribution. It's going to look the same throughout. So if you dissolve something into something else and you can't tell where that thing you dissolved is, then it's a homogeneous mixture. You may have heard this term before with homogenized milk. Milk, when it first comes from a cow, is actually separated into parts and has to go through a process so that it looks like milk that we see. Clear, it's completely white. You don't see the different parts of it. So homogeneous means the same throughout. Solutions are the first type of homogeneous mixture. Mixture that is going to look like a single substance. Solutions, the particles are really, really, really small. Less than 2 nanometers. You don't need to know that number, but it's just to give you a reference. Now, a solute. A solute is the thing that's being dissolved. So let's go back to salt water. If I am making salt water, I'm going to dissolve salt into water. In this case, salt is the solute. Solvent is a substance which is doing the dissolving. So in the case of salt water, water is the solvent. Water is also considered the universal solvent. When you shine a light through any sort of solution, the particles in the solution are not going to scatter the light because they're so small. So examples of solutions are lemonade, salt water, soda, and air. When I talk about soda, I'm not talking about like Coca-Cola or Pepsi. I'm talking more about seltzer water. And the solution is made up of a solvent of water and a solute of carbon dioxide. Air, there is nitrogen as the solvent, and all the other different gases are the solutes. Solubility, that's something's ability to dissolve in something else. And an alloy is a solution containing a metal and other solids, typically a metal and a non-metal like bronze or brass. So when I said it was a mixture last class, bronze, this is what I was talking about. It's an alloy. It's a mixture of, I believe, copper and iron or copper and nickel. Okay, so some examples of different solutions using different states of matter. A gas in a gas would be oxygen and nitrogen, like in the air. A gas in a liquid, sodas, carbon dioxide and water, like I said. A liquid in a liquid. You can dissolve alcohol into water and it produces something called antifreeze. If you don't know what that is, it's something you put in a car so that when it gets really cold, it doesn't overheat, or it doesn't overheat because the water freezes. Because water by itself can freeze when it's really cold. You put alcohol in it, alcohol doesn't freeze. At least not at temperatures we normally see. A solid in a liquid is salt water, and a solid in a solid is brass. Oh, zinc and copper. Got that one wrong. Okay, let's move on. Things that affect solubility. So we're still talking about solutions. So if we're talking about things that dissolve, these are things that affect how something dissolves. When a solid is dissolving, the hotter the solvent that the solid is going into, the solid solute is going into, the quicker it'll dissolve. If you mix it while you're doing it, now this makes sense. If you mix sugar into coffee, it dissolves faster. And crushing a solid makes it easier for the particles to dissolve. So instead of having like a big block or a cube or a tablet, crush it up. When you want to dissolve a gas, unlike a solid, You want the gas and the solvent to be at lower temperatures because the gas is going to want to move around a lot, and if it's moving around a lot, it's not going to do what you want, which is dissolve. Okay, solution info, concentration, that's the amount of solute in the solvent. A high concentration means a high percentage of solute, so there's a lot of stuff being dissolved. Dilute means it's not very concentrated, so it's the opposite of high or concentrated. Concentrated is a lot of solute. Saturated means that if you put any more solute in, it's not going to dissolve. It's going to actually fall to the bottom. And then supersaturated is when you change temperature or pressure so that you can put more in. So you make it a little hotter and you can dissolve some more. All right, I'm going to stop here on this one. So this is elements, compounds, and mixtures part 1, and I will do mixtures part 2 in the next video. All right, see you later.